Good morning, students. In the last lecture, we have seen what is a potentiometer, its uses, advantages, disadvantages, and principle. In this lecture, we will see how we can use potentiometer to compare the EMF of two cells by direct method. The another name of the direct method is what? Individual cell method. Before understanding the working of direct method, first let us understand the circuit diagram of EMF, comparing EMF by direct method. So this is basic circuit diagram of potentiometer used to compare EMF of two cells. Students, electric circuit consists of potentiometer. You can see potentiometer wire is from P to Q. Two-way keys K1, K2 and K. The rheostat RH, galvanometer G as shown in the figure. The uniform wire PQ is connected in series with EMF E, plug key K and rheostat RH is as shown in the figure. Two more EMF of two cells we observe here, E1 and E2. We are going to take the values of E1 and E2 such a way that value of E always be greater than E1 and E2. Value of E is always be greater than E1 and E2. We observe here in the circuit diagram, positive terminal of E1 and E2 connected to the point P, negative terminal of E1 and E2 connected to the one terminal of K1 and K2 respectively. Another terminal of K1 and K2 are connected to the what? Galvanometer G. One terminal of the galvanometer G. Another terminal of the galvanometer G connected to what? Jockey. Jockey is used to slide over the potentiometer wire PQ. How? I will explain it when I will explain working. You can see the theory of the construction of above circuit diagram. Now let us study the working of potentiometer is used to compare EMF of two cells. Students, initially we are going to put a key into the plug key K. Insert key into the plug key K. At the same time, you insert a key into the plug key K1. Keep K2 open. Now connect this jockey to the point P as well as point Q. When you connect to the point P, galvanometer will show some deflection. That deflection should be extreme left. And connect the jockey to the point Q. The deflection in the galvanometer should be extreme right. If you don't get extreme left and extreme right deflection when I connect jockey to the point P and Q, adjust the rheostat so that you will get extreme left and right deflection in the galvanometer. Once you get extreme left and right deflection, then start sliding jockey on the wire PQ. You slide the jockey on the wire PQ till you will get the point P1 such a way that galvanometers will show the zero deflection. Students, when I get point P1, then galvanometer will show the zero deflection. Matlab, current flowing to the galvanometer is what? Zero. That is the balance condition. Once you get that, then we will apply the principle of potentiometer. It states that voltage between point P and P1 is directly proportional to the length of the wire P1. Students, since potentiometer is balanced, we get the balance condition, then E1 is nothing but voltage between P and P1. EMF E1 is nothing but voltage between P and P1. So students, I am going to write mathematically. You can see over here. E1 is voltage between P and P1. Since according to principle of potentiometer, VPP1, voltage between point P and P1, is directly proportional to L1. If I remove the directly proportional, then proportionality constant will come. That proportionality constant is called potential gradient. Then from 1 and 2 we observe that we are going to replace VPP1 by E1. So E1 equals to K times of L1. This is equation number 3. Now we will remove the key from K1 and we will insert key into K2. Now E2 come across. We will do the same thing. We will connect jockey at point P as well as point Q, so that galvanometer will show extreme left and extreme right deflection. If you are not getting, then adjust the rheostat. Once you get extreme left and extreme right deflection when I connect jockey to the point P and Q, then start tapping jockey on the wire PQ till you will get point P2. Point P2 is that point where galvanometer will show zero deflection, means current flowing through the galvanometer is what? Zero. Therefore E2, now E2 is equals to voltage between point P and P2. Students, I will show mathematically over here. E2 is voltage between point P and P2. Now we will apply the principle of potentiometer. Voltage between point P and P2 is directly proportional to length of the wire between point P and P2. Let length of the wire between point P and P2 be L2. If I remove the directly proportional, then proportionality constant will come. The proportionality constant is called potential gradient. Then from 4 and 5 we observe that E2 is equals to what? KL2. E2 is equals to what? KL2. This is equation number 6. Now observe equation number 6 and equation number 3. We are going to divide equation 3 and 6. So dividing 3 by 6. So what is the left hand side we observe here? E1 and E2. So E1 upon E2 is equals to what? K times of L1 upon K times of L2. KK get cancelled. Then what is the remaining terms? E1 upon E2 equals to what? L1 upon L2. So we can compare two EMF of two cells by comparing their balancing length. Students, if you know one of the value of E1 and E2, you can easily find out the another value of EMF of a cell. Thank you very much.